Okay, so have you ever wondered how a massive website, think about a huge product launch or a streaming premiere, can handle millions of people all clicking at the exact same time without just completely crashing? Well, the answer is this invisible hero of the internet. And today, we're going to pull back the curtain on what a load balancer is and why, honestly, you probably couldn't live without it.
So let's start with something we all know. Just picture your favorite app right now. Could be your social feed, a streaming service, anything really. You tap, you scroll, and everything just works. It's instant. It's seamless. But what happens when it's not just you? What happens when millions of other people are trying to do the exact same thing at the exact same second? Maybe they're all trying to buy concert tickets or watch a live game or get breaking news.
I mean, you can just feel the pressure, right? The servers behind that application are getting hit with a digital tidal wave. So what's the secret weapon? What's the magic that stops the whole system from grinding to a halt? That is exactly what we are here to break down.
It all starts with something called the single server problem. See, when an application is just starting out, one computer, one server can probably handle all the user requests just fine. But then you get popular, and suddenly that success becomes your biggest bottleneck.
And this is a super common story. You start out, everything's great, then you get more users and things start to slow down. Then a huge traffic spike hits and boom, system overload. Your app is down. Now sure, you could just buy a bigger, beefier server. That's called vertical scaling. But you'll eventually hit a limit. The real, long-term solution is horizontal scaling. Instead of one giant server, you get more servers.
And this right here is where our hero finally enters the picture. Because as soon as you have more than one server, you need a way to decide which one gets the next request, right? And that, my friends, is the job of the load balancer. You can think of it as the internet's tireless, totally unsung traffic cop. Its whole job is pretty simple, actually. Instead of users hitting your servers directly, they all hit the load balancer first. The load balancer then looks at all the servers it manages and intelligently directs each incoming request to a server that can actually handle it. The main goal? Just keep that traffic flowing smoothly and make sure no single server gets overwhelmed.
So let's trace the journey of a single click. You, the client, send a request, but you don't send it to a specific server. You send it to the load balancer's address. The load balancer grabs it, picks a healthy server from its pool, and forwards your request along. That server does its work, gets the data, renders the page, and sends the response back to the load balancer, which then finally passes it back to you. The key thing here is that you, the user, have no idea this dance is even happening. It's completely seamless.
Okay, so we know the load balancer is a traffic cop, but how does it decide which lane to send the next car into? It's not just random. It actually uses a bunch of different rules or algorithms to make really intelligent decisions. This is the brain behind the whole operation. And these algorithms really fall into two main camps. On one side, you've got static algorithms. These are simple and predictable. They just follow a fixed pattern, like send to server 1, then server 2, then server 3, and repeat. On the other side, you have dynamic algorithms. Now, these are much smarter. They actually check on the health and the current workload of each server before deciding where to send the next request.
And here are some of the most common ones you'll see. Round robin is the most basic. Just take turns. Weighted round robin is a variation for when your servers aren't all the same size. The more powerful servers get more traffic. Least connections is a really smart one. It sends the new request to whichever server is the least busy right now. And then there's IP hash, which is super important. It makes sure that requests from the same user always go to the same server. Why does that matter? Well, that's how your shopping cart remembers what's in it as you click around a site.
Now, load balancers also come in two main flavors, which you can think of as fast and smart. The fast one is an L4 load balancer. It only looks at basic network info like an IP address. Think of it like a mail sorter that only reads the zip code. It's super quick. The smart one is an L7. It can actually look inside the request. It can read the specific URL you're trying to go to. This allows for way more intelligent routing, like sending all requests for videos to special video servers, while all requests for images go to a completely different set of servers. Okay, before we wrap up, we have to clear up a really common point of confusion. People often mix up load balancers with another piece of technology called an API gateway. They both manage traffic, which is why it gets confusing, but they actually solve very, very different problems. Here's the easiest way to think about it. The load balancer is our traffic cop. It cares about one thing: reliability. Its job is to spread traffic out to keep the system from falling over. The API gateway, on the other hand, is more like a building's front desk receptionist with a security badge. It cares about who is making the request and what they're asking for. It handles things like security, authentication, and making sure nobody is spamming the system.
And this is the real takeaway here. They aren't competitors, they are partners. In almost any large-scale system, you don't pick one or the other, you use both of them together. Often, the load balancer will actually sit right in front of the API gateway, making sure that the gateway itself doesn't get overwhelmed. They work as a team to create a really reliable and secure front door for the entire application.
So let's bring it all home. Why is this humble load balancer so absolutely essential? Well, it's because it provides the fundamental pillars that allow any modern application to grow, to scale, and most importantly, to stay online.
I mean, the benefits are just huge. Scalability lets you handle those sudden traffic spikes without breaking a sweat. High availability means that if a server goes down, the load balancer just stops sending traffic to it, and you, the user, never even notice. All of this leads to better performance and, ultimately, a reliable experience that keeps an application running smoothly. So the next time you're streaming a movie or you manage to snag those impossible-to-get tickets, just take a second to remember the silent guardian working behind the scenes. Your favorite app might be running on dozens or even hundreds of servers. But the entire internet? It's kept online by countless load balancers, preventing digital chaos and making the web as we know it actually work.